Okay, this is 8.2. We're going to be dealing with quotients now. So remember, what key operation has quotient with it? Division. So we haven't done anything with division. This is a little different. So what we're going to be doing here in words for the quotient of powers property, you might want to continue with your different colors. We're going to divide powers with the same base, and what the exponents are going to do is we're going to subtract. So they both have a base of a. So what we're going to do is a minus n. We're going to have subtraction there. Now, a couple things. Just to remind you, before this we had done a to the m times a to the n, and that was a to the m plus n power. So multiplying was adding the exponents, dividing is subtracting the exponents. Now, why would it say a can't be 0? If I put a 0 in on the bottom, think about your answer before you say it. What is anything divided by 0? Let's say I have just a random number here, 23 divided by 0. You didn't say 0, did you? You said undefined, right? That's what I thought. It's undefined. So we can't have a be 0. We can't have the base be a 0 down there. Okay, so an example with numbers, same base. That would mean the exponents are subtracting. 7 minus 2 is 5, so it's 4 to the 5th. Okay, so let's look through example 1. We'll do a few more of these. So 6 to the 12th divided by 6 to the 5th becomes 6 to the 12 minus 5 power, or 6 to the 7th. All right, here's a negative number. We have our parentheses around it, so we make sure that we are dealing with exponents and thinking about what happens there. So it's 7 minus 4, which is negative 2 to the 3rd power. Negative 2 times negative 2 times negative 2. Okay, now they're going to start adding in a few other little things. So this is a problem like we've done before, where we have the numerator and there's something to do in the numerator and then a denominator. So when you have fraction problems, it's numerator, then denominator, then divide. So our numerator is not in simplest form before we can divide, so we need to do that right now. So that would make it 4 to the 2 plus 8 power, which is 4 to the 10th over 4 to the 4th. Now we can divide, which means we do what to our exponents? Subtract them. So that becomes 4 to the 10 minus 4 power, which is 4 to the 6th. Okay? Now this one, it would be like multiplying fractions straight across. If I put this over 1 times y to the 12th, that's how that got on top. Y to the 9th times 1, that's how that got on bottom. And now I have the same base, so I subtract the exponents. It becomes y to the 3rd. All right, so that was quotient of powers property. So let me go to the next page here. The next one we're going to do is power of quotient property. Power of a quotient. Okay? All right, so to find a power of a quotient, find the power of the numerator and the power of the denominator, and then divide. So see what's happening here? We have a fraction inside, or a division problem, with a power on the outside. So it would be like we did before when we had a power on the outside there. We'd kind of distribute the power to each term. B can't be 0. If it was 0 on the bottom, it would be undefined. So in this problem, it would be 4 to the 3rd over 7 to the 3rd. All right, an example right here says simplify the expression. This would be r to the 5th over s to the 5th. All right, now this guy in here, let's think about what this means. Where does the negative sign go? It's out in front. So it could be up on top or it could be up on bottom. We like to put it up on top, so I'm going to rewrite this problem with it up on top. It doesn't go to top and bottom. If it was on top and bottom, a negative over a negative is a positive. Now that we have that, we're going to give each one the power of 3. I had to keep the parentheses around the -4 because it was a negative. W doesn't need parentheses. Okay? Now, we could leave it like that, or they have actually some equal sign here. They want us to finish the problem off now. So when there's variables and numbers in the same problem, they want you to finish it off. Versus up here, there were just numbers, so we just left it. Variables and numbers, they want us to actually do -4 to the third power, which is -4 times -4 times -4. So -4 times -4 is a positive 16. Positive 16 times -4 is negative 64 over W to the third. And if you wanted to use their same notation of putting it back out in front, you could do so as well, or this answer would be just fine. Okay, so there are 4 problems to do it out at the bottom. Go ahead and pause the video and then come back and see how you did. Okay, so let's see how you did. So this one, you kept your parentheses around your negative. It's a division with the same base, so we subtract the exponents, and it becomes -8 in parentheses to the third power. We don't need to find the final answer because this wasn't a problem that had numbers and variables in it. The next one, we have a numerator and denominator problem, and the numerator is not simplified. We add the exponents, which makes it 3 to the 9th power on top. Then we can subtract the exponents and get 3 to the 6th. Again, that's good for my final answer. These two at the bottom have numbers and variables, so I need a final simple answer. So number 3, I ended up putting parentheses around the whole thing like there was, but I moved the negative to the top. So then it goes down to this step where I put the squared to both of them. So it's -r squared and 3 squared. Well, 3 squared is 3 times 3, which is 9, but if you're having trouble getting the r squared, here's my work over there. -r squared means -r times -r, or you could write it as -1r times -1r. And then you have to remember the exponent of r on both of these is 1. The exponent is 1 on the r's. So a -1 times a -1 for the coefficient is a positive 1. Now dealing with the exponents. Same base as r. What is 1 plus 1? There are 2 r's there, so it's r squared. And I just dropped the 1 in front to keep it as r squared. Okay, the last one over here, 5 to the 4th over t to the 4th, 5 times 5 times 5 times 5. We worked it out because there were variables in the problem as well, so it's 625 over t to the 4th. If you're having trouble with those, see Mrs. Wyman so that she can help you out. Okay, so we have a few more here, and it's basically putting all the properties together. I'm going to be listing what properties I'm using each time, but it's not necessary if you're worried about, man, I can't remember the name of that property. It's just to help you along right now. So the very first thing that we're going to do here is, since this whole thing is being raised to the third power, I'm going to split it up into a numerator and a denominator problem. Okay, and that was power of a quotient property. Okay, now I'm going to deal with the numerators and the denominators. So let's focus on the numerator right now. Each one is being raised to the third power. So 2 is to the third power, and it's 2 to the 1st times, or going to the third power, so it's 1 times 3 is 3. And then y to the 7 times 3 power is 21. So I'm going to write it out 7 times 3. And the bottom, I'm going to just leave it there for a second as y to the 5th raised to the third power. So that's power of a product. Okay. So now that we have that, we're going to do those exponents. So 2 to the third power is 2 times 2 times 2, which is 8. Y becomes to the 7 times 3 power, which is 21. And on the bottom, we'll do that same step right now. It's y to the 5 times 3 power, or 15. And that's power of a power. The last thing is look at, I have a base of y on top and on bottom, so those can simplify. The 8 still stays there. The y becomes 21 minus 15, and 21 minus 15 is 6, and that was quotient of powers. Okay? All right, so there's 4 to do on the bottom. I'm going to have you stop and try them and then check the answers, and then I'll actually work them step by step with you if you need help on those. So go ahead and pause, try it out. Okay, here's the solution. So number 9 is 49 y to the 5th z squared. That was number 5. Number 6 is 16 st squared. Number 7 is 8 m to the 6th n to the 3rd. That was number 7. And number 8 is 64 a to the 5th b to the 10th. If you got 100% on those and you're good, then you can just stop watching the notes right now and you can continue on to the next step. If you didn't get these correct, I'm going to go through them step by step right now. Okay, so continuing on here, there's a couple things you can do differently in each problem. I'm just going to go through with what kind of catches my eye right off the bat. So I see that this is raised to the 2nd power, so I'm going to kind of distribute that power. So 7 squared, because it's 7 to the 1st, 1 times 2 is 2. Y becomes y to the 3rd, y to the 3rd becomes y to the 6th. So 3 times 2 is 6, and this is z to the 1st. 1 times 2 is 2, so that's z squared. On the bottom, this is y to the 1st, so it becomes y squared. Okay, so from there, I'm going to simplify anything that can be simplified. So 7 squared is 7 times 7, or 49. And I'm noticing my y terms right now have the same base, so it's 6 minus 2, which is 4. And z squared, there's no other z terms, so it just gets rewritten. So that is 49 y to the 5th z squared. Oh, yep, that's right. I think that the answer I read before of the note-taking guide was incorrect because they did not distribute the 2 right here. So if you were watching and you were like, I think that answer was wrong, you're right, that answer was wrong because they only did y to the 1st there. So they did 6 minus 1 is 5, but it's not, it's 4. So I hope that you did that correctly. Good one for us. We caught a mistake in the book. Okay, the next one, we are going to do a couple different things. I'm going to deal with the 2nd term first of all. So I'm just going to rewrite the 2s to the 4th over t. Rewrite my multiplication sign. I'm going to distribute that 3rd power. So it becomes 2 cubed t cubed s cubed. Okay, so then I want to deal with the 2 cubed. So I'm going to keep them separate. 2s to the 4th over t equals 2 times 2 times 2 is 8, not equals times, is 8 t cubed over s to the 3rd. Okay, so now I'm going to multiply, and I have coefficients here that are numbers they can multiply together, so it becomes 2 times 8 is 16. The s to the 4th gets rewritten on top, the t to the 3rd gets rewritten on top, and then on the bottom I write them in alphabetical order, so I rewrite s to the 3rd over t. So now my coefficients are settled. They're 16 on top. Then I have s to the 4th over s to the 3rd, which is just s. T to the 3rd over t to the, remember, first is t squared because I subtract them. That's what the book had. Okay, the next one. So this one, I'll simplify first before I deal with the exponent of 3, just to show you that we could have done that in a couple other places. So we're going to do 6 divided by 3 right now, which is 2. Then it becomes m to the 3rd over m to the 1st, so that's 3 minus 1, which is 2. So it's m to the 2nd on top, and n to the 1st there, so 2 minus 1 is just an n on top. So everything on the bottom ended up canceling out, and I'm to the 3rd power there. Okay, you could have dealt with the 3rd power first if you wanted to. Okay, so now I'll deal with that. So I have 2 to the third, m to the 2 times 3, which is 6, n to the 3, 1 times 3, which is 3. And then one final step. 2 times 2 times 2 is 8. So my final answer is 8m to the 6th, n to the third. Okay, last guy. So this one, woo, it looks pretty complex. So I don't know what I want to do first. I think I'll deal with these a's right now just so I end up not dealing with division there. So I'm going to do 4a over b squared in this part. And then over here for this one it becomes 2a to the first, b to the third, and then that's to the fourth power. Now I'll deal with that fourth power. So it's 4a over b squared times 2 to the fourth, a to the fourth, b to the 12th, because we're multiplying those exponents. Okay? So now it's almost as if this is over 1. We're multiplying across in fractions. So before I do that, I probably need to deal with this 2 to the fourth power because I have to multiply that by 4 there as well. So we'll have 4a over b squared one more time. 2 to the fourth is 2 times 2 times 2 times 2, which is 16. A to the fourth, b to the 12th, all over 1. Now I can multiply across. So 4 times 16 is 64. A to the first times a to the fourth. We add the exponents to make a to the fifth. B to the 12th just gets rewritten. And then on bottom we have b squared. Phew, we're almost done. 64, those are the only numbers left, so it's good. A to the fifth, only a numbers left. And b to the 12th over b to the second is 12 minus 2, which is 10. So there's my final answer. Okay, so you got practice to do on 8-2 now. Certainly see me if you need help on one of those.